On behalf of New Millennium Building Systems, welcome to Improving Multi-Story Building Design. This is a nano course, a quarter AIA Learning Unit, HSW accredited continuing education course. Let's take a moment to review the course provider statement. Certificates will be issued afterwards with the successful completion of a short test. The learning objectives for this short course is to gain a working knowledge of the three types of long-span composite floor systems that support multi-story design and construction: composite joists, dovetail composite, and deep-ribbed composite. Installation images of these three unique systems. This multi-story course applies to construction for both residential and commercial projects. Graphic cross-sections illustrate the distinguishing profiles of these systems. The joist, with its characteristic diagonal web members, has a standard deck. Dovetail and deep-ribbed deck represent deck-only long-span composite floor solutions. Let's start with composite joists. Similar to its counterpart in roof applications, the composite joist has its familiar shape, the defining feature being the studs welded to the top chords of the joist. You will also note the composite floor deck with its identifying trait, embossed sidewalls. Composite steel joists allow long, clear spans beyond 60 feet. Compared to wide flange beams, they are significantly lighter. That can, in turn, lighten the entire structural system. In its totality, there is an overall reduction in steel. This leads not only to material savings, but also in manufacturing, shipping, on-site staging, and erection costs. The combined time saved may even lead to earlier building occupancy. Composite joists require no shoring, and identical to roof joists, building system integration is accompanied by the web openings. For larger ductwork, the webbing can employ the design of a Verandil. A composite joist floor system is efficient to build and readily deployable in any market. In this instance, we'll assume a cold-formed steel bearing wall, but it can be a component in any structural system, steel or concrete tilt-up, for example. The joists end bearing in this scenario, followed by the bridging. And it should be noted, bridging types and end-bearing conditions like top chord extensions are elaborated on in full-length courses. The composite deck can be either a form deck, 1.5 inches, 2 inch, or 3 inches deep. Shear studs, followed by welded wire mesh, all come together to establish a unified, load-bearing system with the concrete topping slab. The structural goal is the composite action. Both the deck and the joist have a means to key into the concrete. This bond combines the tensile qualities of steel with the compressive qualities of concrete. Additionally, the concrete topping slab may provide benefits in fire rating and vibration. This varies on total slab depth. Again, we see the combination of the concrete to steel, playing to each material's advantage. The shear studs attached through the decking to the joists embedded in the cured concrete. Note that composite joists, to achieve a fire rating, would require protection. That could be in the form of fire-resistive coatings like intumescent paint, or boxing them out in a fire-rated gypsum wallboard. The result can be concealed in a drywall hard lid or exposed, contingent on aesthetic goals and fire rating for the occupancy. Composite joists are just one option for large-scale open floor plan projects, ideal for the expansive showroom of this Ferrari dealership. Next, we'll shift our attention to dovetail composite. This profile has options in 2 inch and 3.5 inch, having long spans relative to thin floor plates. With simple spans able to achieve 17 feet and continuous spans up to 28 feet, projects can go up quickly and efficiently without specialized labor. A major advantage of the system are the fire-rated designs. The classic slab design is the 2-inch dovetail that with a 3.25 inch topping slab elicits a 2-hour UL-rated assembly in only a 5.25 inch total slab depth. The assembly has multiple variables, creating flexible solutions based on the design team's criteria. Specifying lightweight concrete in lieu of normal weight, the cover is reduced, lightening the entire system. Picking up an hour rating from Type X gypsum wallboard can also reduce concrete volume. Solutions can result in gaining full performance with only a 4-inch total slab depth. These monolithic thin floor assemblies create floor-to-ceiling heights and optimize total building height. Panelizing metal stud walls has revolutionized mid-rise construction. All the benefits of steel construction economize to fit into any project budget. Assume the middle bearing wall requires fire separation. Next come the row of temporary shoring in yellow. An alternative design, like using 3.5-inch dovetail, may be able to simple span a given condition. But in this animation, we're assuming the 2-inch dovetail requires at least one row of shoring. Pour stops prior to the deck installation. Again, the erection is similar to any composite floor deck. Note the accessory at the head of wall. We'll come back to that in a moment, as the dovetail deck is installed. Dovetail composite is ideal for mid-rise construction. The market has seen the greatest benefit is multi-story residential. These are hotels, dormitories, senior living, any kind of multifamily design. Let's focus on the cutaway of the assembly. The deck bearing on metal studs, concrete filling the cavity. No permanent interstitial beams, only temporary shoring until concrete comes up to strength. The result is an uninterrupted fire-rated slab. Transitioning to the head of wall detail. This is the brake metal accessory mentioned during the animation. It creates a condition that does not require fire sealant at this condition. Sealants can be expensive and labor-intensive to install. By offsetting the dovetails, it creates a UL-rated head of wall, eliminating potential fire transfer at the bearing wall between the units. The concrete cover is continuous. The fire sealant would be required at conditions in which the deck flutes are not staggered, either continuous spans or end-of-wall conditions. Strategies to streamline and address constructability are elaborated upon in the hour-long course. Additional accessories available by the deck manufacturer are hanging devices specific to the dovetail profile. They are typically used for lighting, plumbing, and ductwork. The wedge-shaped hangers are adjustable and can be relocated anytime if desired. Now, that's not typically a strength of the residential system, and it's more so popular in exposed roof deck applications, as it avoids the need to permanently puncture the deck. Critical to any successful project is properly addressing acoustics. In residential construction, the key metrics are sound transmission class and impact insulation class. 50 for each is the bare minimum. Building up the floor assembly or ceiling assembly helps to boost STC and IIC. Commercial applications like a multi-story office with an open floor plan are concerned with a different aspect of sound, NRC. Acoustic ceiling tile is the standard fare solution to ambient noise, but there are ways to address NRC values by exposing the floor deck. Dovetail Composite Acoustical, in the upper right-hand corner, gives the design team the aesthetic of an architectural deck with a performance that can transcend acoustical tile. Cold form steel or light gauge metal framing is replacing platform wood construction around the country for a number of reasons. Wood is susceptible to dry rot, insects, and fire right up until the moment that it's rocked. The design flexibility of wood and steel may be similar, but the quality and longevity of steel is a substantial improvement. Building owners have embraced composite design and its long-term value. We'll continue with a long-span composite floor system that you may not be so familiar with, deep-ribbed composite. As with the other systems, this is equally applicable for commercial and residential construction. Unlike composite joists and dovetail composite, however, or even other steel products in general, even wood construction, deep fluted deck is competing more so with concrete. both precast planks and post-tension. It can achieve the spans of concrete, but up to 40% lighter. Seismic areas of the country find this particularly advantageous. The deep rib deck profile provides for long, clear spans, up to 36 feet, in a total slab depth less than 12 inches thick. For less shoring during construction, the system can support unshored spans up to 22 feet. Another variable is the density of the concrete, 4,000, 5,000, and 6,000 psi. This puts a lot of factors in play to tailor your custom optimal solution. 3 progressively deeper profiles are typical of these systems: 4.5, 6, and 7.5 inch nominal. Residential tends to utilize the 4.5 and 6 inch hats for long span composite design. They all have counterparts in cellular acoustical options, and those profiles tend to favor commercial office construction. We'll talk about that when we address acoustics. Let's discuss fire ratings. Simply put, the addition of 5-inch normal weight or lightweight concrete cover yields a 2-hour UL unprotected floor assembly. 4.25 topping slab yields a 1-hour rating. Similar to dovetail composite, we do see quite a few solutions opt for the protected assembly, since having a hard lid in gypsum wallboard is most prevalent in both commercial and residential construction. No matter what the application is, the cavity can always be maximized for chaseways. 3 examples here showing a light, fire suppression, and diffuser. To maintain consistency, we'll go back to our metal stud wall animation. As you'll see later in the presentation, in addition to light gauge metal framing, deep fluted deck is adaptable to any structural frame. Due to its profile depth and shape, the deck can simple span our 30-foot by 40-foot example with only a single row of shoring at midspan. The deck hats, at 12 inches wide, can easily be maneuvered into place with as few as 2 workers. Note the closed ends. This is done in line at the deck mill during the production process. This facilitates a concrete slab beam at the supports without installing any additional accessories or brake metal piece. Welded wire mesh goes down, and there may be possibility for reinforcing bar to supplement. And as with any deck, the temporary shoring is removed when design strength is reached, allowing for the other trades to start their scope. We'll zoom into a graphic cutaway. The closed ends on display, the side laps are self-aligning and nesting. A proprietary tool to stitch the side laps can expedite the process, but not necessarily required. Concrete keys into the steel, creating a mechanical bond at the connection, adding to the structural capacity. As mentioned, deep-ribbed composite can be supported by any structural system. Structural steel options include steel channels, wide flange beams. Trying to maximize the clear floor height, one solution is dropping a ledger in the web of the wide flange. That's shown in the upper left-hand corner. Bearing on concrete block wall is also a possibility. Even bearing on existing structure. Now, these are projects that are typically aggressive renovations, as with historical buildings being brought up to code or taking on a new life, while trying to preserve its facade and maintain its architectural integrity. In the top middle, let's briefly discuss composite beams. All of the steel beam and column solutions could require fire protection. However, a composite beam does not. Plate steel is press broken into the beam shape. It receives a rebar cage, and once filled with concrete, it creates a fire-rated solution. No need for drywall or intumescent coatings. It is a wholly unprotected system in a monolithic slab. At spans this significant, long-term deflection and floor vibration become governing factors. Verify that the deck manufacturer has several methods to evaluate both vibration and long-term deflection. Acoustical ratings for deep-ribbed composite through the lens of STC, IIC, and NRC. Long-span composite systems have identical paths to blocking sound transmission, either supplementing floor or ceiling materials, typically both to increase STC and IIC. As for NRC, again, think of our open office and the need to absorb as much sound as possible. These are the cellular acoustical profiles shown on the lower right-hand side. They offer substantial NRC valuations instead of suspending a secondary ceiling. This profile is a variation and features a shop-welded liner panel to create a flat bottom appearance. Again, you can still access the chaseway. These solutions can apply for any kind of multi-story project. And lastly, let's discuss panelizing. The next evolution of steel construction will be some form of prefabrication. As it currently stands, this can be done at the project site, laydown space permitting. Structural bays are assembled on the ground, and the deck sections are craned into place. Eventually, this work may be accomplished off-site in a controlled environment. The three systems bring greater creativity to multi-story building design and construction. In conclusion, they are increasing the overall building performance and achieving the desired aesthetics. You can learn more by taking our full credit hour course on these topics. Thank you so much for your time today. We appreciate it.